Okay, let's answer this question. This is a theory question from WAEC. So let's answer it and see how to analyze current electricity or basic electric circuits. So this is the circuit here, and it says if A1 reads 4 amps, calculate the first one I, equivalent resistance of the combined resistors 2 ohms and R ohms. II. Calculate the current through A2 and A3. And the third question, the value of R. So we have to calculate, we have to first calculate the equivalent resistance in the circuit. Then the second one, we have to calculate the current through each of those resistors. Then the third one, we calculate the actual value of this resistor here labeled R ohms. So let's quickly start work. Now, how do we get the equivalent resistance? You know this, what connection is this? This is a parallel connection. This first resistor is connected in parallel with this one. So if we do parallel combination, that should give us the equivalent resistance. But however, that formula will not give us the equivalent resistance because R here is unknown. The second resistor here is unknown. So we are not going to use the resistors to find that equivalent resistance. And here we've been given the EMF 9 volts and the internal resistance of the cell. Now you will recall that EMF or electromotive force is equivalent to voltage drop across the external resistor or resistance plus the voltage drop within the cell itself, which equals to current through the circuit times the external resistor plus current through the circuit times the internal resistance. So you end up having, you factor out the current, which is the common factor there, big R plus small r, and that will give you what? E, the equivalent, the electromotive force. So electromotive force is the voltage read by the cell or battery when it is in open circuit. That's when it is not connected to any other thing or to a load. Now that is not the same voltage that same cell will read when you connect it to a load. When you connect it to a load, the voltage it will read then is what we call terminal potential difference. What we call what? Terminal potential difference. That means it is the potential difference or the voltage measured when the cell is supplying power to an external load, and it is represented by this I times big letter R, or you say V, representing terminal potential difference equals to what? I times R. So this particular one here represents the terminal potential difference, while this one I small letter R represent the voltage drop within the cell. So we arrive at this formula. So now 9 volts is the EMF. Now it is being supplied to these two resistors. I'm still trying to explain some basic concepts so that when I start in plugging values and do some things I have to do, you won't have much question to ask. So now this EMF here that is now supplying these two resistors, will see the same voltage because they are in parallel. This is a parallel connection, so the voltage across 2 ohms will be the voltage across R ohm. And then, but however, that voltage will not be 9 volts, because this 9 volts represent the EMF. The voltage will be something smaller when you subtract the internal, the voltage drop within the cell. That will now be the remaining voltage, will now be what will be supplied. So however, let's answer the questions. The first question that said that we should find the equivalent resistance, which is this R here, which is this R. So accordingly, we have been given I. Accordingly, we have been given I to be what? 4 amps. Or I'll say I1, which is here. This did I say this A1 or I1 represents the current coming from the cell, or the current drawn from the cell, and which is equivalent to the total current drawn from the cell, because it is this current that is being drawn from this cell. It is this current that is being drawn from this cell. I think my polarity, my conventional current polarity is wrong. So conventionally, current flows through the positive side of the cell, but it's still the same analysis. It's still the same value of current. So now we have to calculate the equivalent resistance. So this A1 here represents the total current. It represents the total current drawn from this cell, and they have said it is what? 4 amps. Now you know that the total voltage or the terminal voltage will be equals to the current times the external resistance. So if we plug our values here, we are going to find R. Is this formula here? This EMF formula that we are going to use to find R. So let's plug in this thing. So here we have 9. So you have 9 equals to, our I is 4, equals to 4 into our R. This R here represents the equivalent resistance. That is R subscript equivalent plus internal resistance of the cell. So we are going to solve this circuit to get our R. So if we solve that, so this is 9 equals to 4 into R equivalent plus 0.5. So you multiply, you divide both sides by 4, so that you have 9 divided by 4 equals to R equivalent plus 0.5. If you make R equivalent the subject of that formula, you have that R equivalent will be equals to 9 over 4 minus 0.5. 9 over 4 minus 0.5. And 9 over 4 is 2.25. 2.25 minus 0.5. If you subtract that, you have 1.75 ohms. So the equivalent resistance, or the combined resistance that this EMF or this cell is seeing is what? 1.75 ohms. That's the equivalent resistance. That's the resistance it is getting from this combination. So we have answered our first question. So our question I, we will have that R equivalent equals to what? 1.75 ohms. So the next question is the current through A2 and A3. Now we don't know the value of the resistance in this resistor here. So finding the current through it will be a bit challenging. However, we can find the current through this first resistor here reading 2 ohms, because accordingly from Ohm's law, you can get that resistance there. If I label that resistance R1, you get that R1 will be equal to what? The voltage divided by the current. Sorry, we are looking for the current through it. We label it I1. So you have that I1 will be equals to the voltage divided, that's terminal voltage, the voltage read across the combination, the voltage drop or terminal voltage divided by R1. So that's how we're gonna find it. So if we are to now find I1 here, with that I1 and A1, that's the total current, we do subtraction and now get the one for R, which is A3, because the current from here A1 is the summation of A2 and A3, because this A1 comes from the cell, then when it reaches this parallel connection, it will divide itself into 2 depending on the value of the resistances. So let me find A2. So to calculate for II, our A2, which is the current through this branch, the current will be what? The voltage, terminal voltage, divided by the resistance, the R2. However, what is the terminal voltage? Because the voltage here, 9 volt, is the EMF. The terminal voltage V equals to what? IR. So I here represents the equivalent current, which is A1. A1 is the equivalent current. A1 is the equivalent current times the equivalent resistance. So that will be 4 times equivalent resistance. Our equivalent resistance is 1.75. 1.75. And that will give us what? 4 times 1.7 4 times 1.75 will give you 7. Will give you 7. So you now have 7 volts. So we have gotten the terminal potential difference. So our A2 now will be equals to 7 divided by our R2, which is 2, the value of that resistance, which is 2. So 7 divided by 2. 7 divided by 2 is 3.5 amps. 3.5 amps. So the current through this second resistor, or you say the value of A2 is what? 3.5 amps. 3.5 amps. So we are going to calculate A3, that's the current through the third resistor. A3. So now A3 can be gotten by saying A1 minus A2. Since A1 is the total current, so the total current minus one of the current, which is this A2, now give us that A3. So this is equal to, well, A1 is 4. 4 minus 3.5 will give us 0.5 amps. So the current through the second resistance, which is unknown, the current through the second resistor, which is unknown resistor, is 0.5 amps. So we have calculated the second question in the question. So the third one says calculate the value of R. Calculate the value of R. Now, since we know the voltage across that R, which is 7 volts, and we also know the current through it, so it's easy to get the resistance. From Ohm's law, we can say the resistance R, or let's label that R3, will be equals to what? The terminal potential difference, or the voltage across the parallel connection, divided by A3, or the current, divided by the current through it. So that will give us 7 divided by what do we get at the current? 0.5 amps. So 7 divided by 0.5 amps equals to 14 ohms. So we've answered the third question. The value of our R is 14 ohms. There is another way to calculate the value of that R. Now, since we first calculated the equivalent resistance to be 1.75, and you know, for the two resistors in parallel, you have the equivalent to be R1 times R2 divided by R1 plus R2. So R2 is what we are looking for. So if you make R2 the subject of the formula here, okay, not yet, we have to do the substitution first. So R equivalent, what did we get as R equivalent? 1.75. 1.75 equals to, our R1 is 2 times R2 divided by 2 plus R2. Plus R2. So you cross multiply, you will get you will get 2R2 to be equals to 1.75. You open bracket. That will then be 2 plus R2. So 2 R2 equals to 1.75 times 2 will give you 3.5. Will give you 3.5 plus 1.72 times that will be 1.75. sorry, 1.75 R2. So you collect like terms, that's 2R2 minus, when you bring this one over, minus 1.75 R2 equals to 3.5. So 2 minus 1.75. 2 minus 1.75 will give you 0.25. So you have here 0.25 R2. R2 equals to 3.5. So after this, if you divide both sides by 0.25, you then have that your R2, or the unknown resistance. This divide this, you have 14 ohms. So that's another way to do it, but that method is a bit long. So it's really simple. You go through the first easy method, terminal voltage divided by current will just give you that instead of going through this long process. So that is how to answer this question. So you like the video and subscribe to the channel to move the ministry forward. And then for online tutorial, you can join my WhatsApp group through the link in the description. That's for real-time online classes you learn from me directly. Okay, thank you.